And let me just scroll down here just a little. You know what? See, that's the challenge. I have so many start here's. I'm recognizing that example. I'm like, we already did that. So then I scroll down some more and I see a start here Tuesday. I'm like, whoa, okay, wait. Then I scroll down some more, start here. So yeah, that's what I thought, because I was telling my daughter this morning that today we're covering the logical operators. So I should probably be more specific with my start here. So we would have been covering stuff we've already covered. So that was my fault. Good, let's fresh recording, get to start with this. Logical operators, this makes our life easier. So on that example that Chloe was so kind to share, the reason that we coded it that way was because at the time of solving that problem, we had not studied logical operators. So one of the problems I was just going over with my daughter prior to coming in to this to this Zoom session today, one of the Replit problems was looking at if you scan a number. So imagine we just have number equals int input. Okay, we just scan a number. I'll put here enter an integer. Okay, and the Replit said if the integer is if the number entered is a 3-digit number, print yes, otherwise print no. If it's a 3-digit number. And so first you have to think about it. Well, how do I count the number of digits? Well, you don't need to count the number of digits. You have to just realize, what is the possible range of 3-digit numbers? 3-digit numbers start at 100, right? 99 and less are not 3-digit numbers. They start at 100 and they go up to what? Someone answer quick.
999.
They go up to 999. So we don't need to, there are other ways in Python to have solved this problem that we haven't learned yet, but just based off of knowing numbers and knowing which are the 3-digit numbers, we could have really solved this by, if we knew logical operators, I could have said if num is greater or equal to 100 and num is less than or equal to, if it's less than or equal to 999, print yes, otherwise, else, print no. That's pretty easy to do. That's so much easier, in fact, than what we were doing last week. But because we did not know and, we had not learned that yet. Here you had to use nesting. We had to say, well, if num1 is greater than 100, well, that's part of it. But the other thing I need to check is if num is less than or equal to 999. And if it is less than or equal to 999, only then do I print yes. Only then do I print yes. But else, if it's not less than or equal to 999, I need to print no. And this would have been a solution. So here, remember, the indentation is vital, is so vital. This is how we actually understand what's going on in Python. So here, if num is less than, so notice, what's this question being, what is this exact Boolean expression doing? It's asking if num is greater or equal to 100. If that is false, if that statement is a false statement, what does num have to be? Quickly, someone.
A 2 or 1-digit number.
Sure. So, but just give me the exact statement. That's a correct answer, David. But I was looking for something else. So if num is not greater, if num is not greater or equal to 100, it has to be
false.
Sure. So if it's false, if it is
Less than
false,
100.
It has to be less than 100. That's what I was fishing for. David, you said correct answers the whole time. I was just fishing for something particular. So I need to maybe, I always use a fishing example, even though I don't fish. So I need to bait my hook better, I'll have to assume. So yeah, basically I'm saying if num is greater or equal to 100, that's what this statement is asking. Well, if that statement is false, what does that mean? That means that num has to be, by virtue, has to be less than 100. Well, if it's less than 100, and it's false, we're going to come right here. we have to go to the matching else. And remember, I wanted to cover this example because it's a great one. The matching else is the one that matches up vertically, like it falls right underneath that if. So we go to the matching else and we print no. Now, what if num, so here if the input, if num was 50. So imagine if we said num equals 50. If num was 50, this here would be false, okay? And we're gonna therefore come to the matching else and we print no. Fantastic. What if num was 500? What's gonna happen? Well, this will be true, and we're gonna come inside. So we start at this if statement. If num is less than or equal to 999, well, that is now also true. That statement is true. So we come inside that if and we print yes. And because this if on line 49 is true, we don't execute lines 51. We don't execute that else statement and its code inside it, the print statement. And also because the line 48 is true, we don't execute any of this. You don't execute a matching else if the if statement were true. So if num is 500, we would print yes. So let's look at the final example. What if num was not 500, it was 5,000? So if num is 5,000, that first if statement on line 48 is true, because it in fact is greater than 100. So now we're going to go inside that if, and we're going to look at all of this code right there. Is num, so start on line 49, is num less than or equal to 999? The answer is false. So we don't execute that line of code. We don't go inside the if. Instead, we go to the matching else, which is right here, and we print no. And of course, this doesn't get executed. Can someone tell me why lines 53 and 54 don't get executed? I need someone, quick.
Because the program went into the original if statement, so it'll skip the last else statement.
So I guess maybe correct. Maybe a better way. I always try to think of better ways to improve teaching. That here, if we had 5,000, maybe I'll explain it this way. So is this true or false? The answer, that's true. So once that if statement evaluates to true, just cross that out. We're not going to even do that. We're not going to go there, right? And so now we come inside here and we look at this if statement. Is that true or false? That's false. So we're not going to even do this one. And we come to this else and we come to this print statement. Okay, so all of this, I just want to go over that one example. For what reason? To tell you, because since we had not covered what we're going to cover today with logical operators, this became more convoluted than necessary. It did not have to be that difficult. With what we're going to learn today, we can simply type and if this thing is true, so we're really checking two truths at once. Okay, so I'll introduce this subject by looking at this example. So if num on this example were, again, let me get my pen back. If num were again equal to 500, we're going to look at this if statement on line 48. And we say, well, that right there, that's true. And we look now at this right here. That's also true. Sorry, there's something wrong with the code. That if statement isn't supposed to be there. Okay, so if both of those things are true, then the result is the entire if statement is true because we used and we're going to cover that today. So because we used an and, this if statement is true if they are both true, and then we'll print yes. Otherwise, we print no. So with what we're going to learn today, we're going to see that this is so much easier to code up and solve some of those replets we were working on last week. So let's get back to look at these slides. So these are called the logical operators that we're going to cover today. The not, the and the or. These are logical operators allowing us to create, the technical word is composite conditions. I'll just say compound conditions, okay? So again, we have not, and, or. This terminology of disjunction, conjunction, I'm not worried if you don't know that, but just know that we're going to study ways of gluing together multiple Boolean expressions. And we're going to glue them together using these operators and or, and we'll also use this not operator, which is negation, okay? So let's look at this one particular example here that the publisher gave. We have several pages of it. And we're going to introduce to you the idea of truth tables. So here in this one example, it's not the easiest to follow, so I want to just highlight this. This is the truth table, what I'm highlighting right here. And it should really have, this is from the textbook that I use. It should have been a bit more clear, so I'll do it like this. That's a table, okay? So here we have this variable p. P is a Boolean variable. So P can either be true or false, right? And so if P is true, not P is going to be the opposite. That's what this table demonstrates. So if P is true, not P is false. That's pretty straightforward, okay? If P is false, not P would be true, okay? And so not is an actual, this not is an actual operator in Python. We can actually type not, and then we put the Boolean variable, and it will put the opposite. It will negate it, okay? So follow this example. It says here, so clear. It says, assume that age is 24 and gender is F, female. So here, if we say not age greater than 18, well, first of all, let us break this down. They just told us assume age is 24. Okay, so age is 24. So put a 24 here. Is 24 greater than 18? 24 greater than 18, true or false? Farha, I'm calling out some students. Farha, 24 greater than 18, true or false?
True.
Absolutely. So that's a true statement. Now, if we say not true, that becomes false, okay? Similar, if we have gender was set at F, and now if I say F equal M, Ibrahim, is that a true or false statement? F equal M.
False.
That's a false statement. And not a false statement is going to be true. That's pretty straightforward, okay? So this is the idea of negations, of using not. Let me hit stop. Let's pull up. I want to pull up the garbage file. Recent. Nope. Open. So let us say P equal. I can use any variable. P is just a variable, right? I could say Farha. Sorry, I'll use you Farha. Farha equals true. So we're assigning the value true into Farha. So if I want to print, I can print Farha. It's going to print true, right? But now if I print not Farha, it's going to print false. Pretty straightforward, okay? What if I were to say x equals 5? And then I want to print x is greater than 10. What's going to print on line 3?
False.
So on line 3, we're going to print false because obviously 5 is not greater than 10. That's going to print false, right? And then if I say, how about not x greater than 10? That's going to print true. Just I want you to understand what the not does. I hope that's clear. So with that in mind, let's pull up this next one. Here we have our and our ors. So, and we need to spend a few minutes to study this because for many of us, this is the first time we've ever seen this. That is not the easiest. This is not going to be the prettiest drawing, but I'm trying to actually draw out the table for you. So here is our truth table. And we're looking at and. Okay, so for this truth table, if I have two variables, P1 and I have P2. So I have P1, okay? I have P1. I also have P2. They're both Boolean variables. P1 can either be true or false. P2 can either be true or false. And we want to look at all combinations of that. So the first thing I want you to recognize is that there will be 4 combinations of the possible matches of P1 and P2. So we say, well, P1 can be false. And if P1 is false, P2 to match with it can be false or true. And P1 could have also been true, because remember, we said that P1 can be false or P1 can be true. Okay, so I'm looking right here under this column for P1. So P1 can be false or it can be true. If it's false, when we look at, well, what can P2 be? Well, P2 can be false or true. Also, if P1 is a true statement, if we match P2 with it, P2 can be false or P2 can be true. I'm just trying to share with you that there are 4 possible ways of matching up P1 and P2. Please humor me, and I have to actually see this. Can you share, put your thumbs up if that fully makes sense, that there's 4 possible ways of matching up P1 and P2. If you can share that, please, in the chat. Not in the chat, in the participant window. Put your thumbs up, please. Rebecca, is that okay? Musab, are you even here yet? Rebecca?
Yep, I get it.
Okay, does that make sense, Rebecca?
Yes.
Okay, I just didn't see your thumbs up. That's why I was asking. Cool. So continuing, we have these ways, the 4 ways we can match up. Yeah, if you can take your thumbs down, and actually, I want to wait till all the thumbs go down. Come on. One more. Jonathan Huth, there we go. Put your thumbs up if you've studied truth tables before. I'm even surprised to have that many, because this is not something you normally see until a particular type of math class. You don't really see it in algebra. You don't see, it's not that it's hard, but it's only used in, if you've taken a logic class, or at the college level, we have what's called a discrete mathematics class, which is usually taught in the computer science department, sometime in math departments. So most of y'all, this should be the first time you're seeing this. So here we have P1 and P2, and we want to be able to say, what is the truth value of if I and those 2 things together? And this is not hard. I promise you, it's not hard. For those of you, this is the first time. I'm talking to my 12-year-old daughter, Mariam, as I say that. So, Mariam, unmute your mic for me, please.
Okay.
Mariam, if I tell you that if I say that tonight, oh gosh, if I say on Friday, we're gonna order pizza if you finish all your homework and if your room is clean, then we'll order pizza. I mean, it's pretty straightforward, but you tell me, when are we gonna order pizza?
On Friday,
If what?
if my room is clean and what was the other part?
You finished all your homework. I don't remember what I said. So what if you did not finish your homework?
Then we would not get pizza.
So you get the idea. What if you didn't finish your homework and you also didn't clean your room?
Then no homework and got punished.
Come on, quickly. If you did not do your homework and you didn't clean your room, what about the pizza?
Then we wouldn't get pizza on Friday.
So maybe that's not the best example. Thank you. But here, the whole idea is this statement of if I say we will get pizza if those 2 things are true. So when are they both? Basically, it's going to be true if only both of them are true. Maybe that's not the best explanation. I can think of another one on the fly. But basically, P1 and P2, okay? P1 and P2, that entire statement is true. It's a true statement only if both of them are true. Okay, so let's look at these examples they gave us here. Maybe they're better examples, and I shouldn't try to create some on the fly. Let's look at this. Here, it says assume age is 24 and gender is female. So let's look at this first statement here. Is that a true statement? Well, age greater than 18. 24 is greater than 18. Mariam, is that true or false? 24 greater than 18.
That is true.
Keep your mic open. 24 greater than 18. True or false?
That is true.
And here, gender equal F. True or false? I don't know if you're paying attention. We already assigned right there. Gender was given the value F. So right now, pay attention right here. So gender F equal F. Is that true or false?
It is true.
That's a true statement. Absolutely. So this is true. This is true. And if I have a true and a true, what's the result of that?
True.
Absolutely. That's what we just showed you at the top when I had said, if I have, this is what this line shows right here. The line of the truth table that you see right here says that if P1 is true and P2 is true, then P1 and P2 is true. Okay? That's the important takeaway here. For this and operator, it's true when both of them are true. Okay? But otherwise, P1 and P2 is false. So P1 ANDed with P2 is false when P1 and P2 are both false, when P1 is false and P2 is true, or when P1 is true and P2 is false. Now that might seem like a lot to memorize. You don't have to memorize anything. If I just simply ask you in plain English, P1 and P2 and P2, when is that going to be a true statement? Someone tell me, when is that going to be a true statement? The answer is simple in English.
When both are true.
When both are true. When both are true, that is a true statement. So you know what? The example I gave of the pizza wasn't the best example. Let's do this right now. Someone tell me if my statement is, Mariam, can you hear me?
Yes, I can.
Tell me if the following statement is true. Mariam is upstairs right now on the computer and her name is Michelle. Is that a true or false statement?
False.
Because one of my statements was false. Does that make sense?
Yes.
That's a weird example I just gave. So let's do this again. Let's pick another one. Today is, yeah, the pizza example wasn't a good one. Here's a better one. Today is Tuesday and tomorrow is Friday. Is that a true or a false statement?
False.
That's a false statement because I made two statements. I connected them with and, but one of them was not true. So therefore the whole thing is not true. Does that make sense?
Yes.
So what if I say today is Wednesday and tomorrow is Sunday? Now, is that a true statement?
Today is Sunday, tomorrow's Monday. Yes.
What?
Today is Sunday and tomorrow's Monday, right?
No,
That's
I
what
said today
Okay.
is Wednesday and tomorrow is Sunday.
Okay, then no. False.
They're both,
I heard
because
that
both
too.
of my statements were false. So so what if I say today is Tuesday and let me look outside and it is blue skies outside? Is that a true or false statement?
Today is Tuesday and it has blue outside, so yes.
It's a true statement. So all you're doing is you're analyzing both of my individual statements. You're checking the truth of both of them. And since they're both true, the whole thing must be true. Does that make sense?
Yeah.
Now, what if I change my wording? So this actually I see on the slide as a typo right here. That should say or. So this should say or, okay? Because we're looking at the truth table for or now. So now, again, it's pretty straightforward, but let me just say it anyway. What if I say, today is Tuesday and Disney World is open for business? Is that a true or a false statement? Quick. Today's
False.
Tuesday and Disney World is open for business. That is a false statement because we all know that Disney World is shut down right now, right? So, but now let me change. Listen, I just said today is Tuesday and Disney World is open for business. So now I'm going to change my wording. Today is Tuesday or Disney World is open for business. Is that a true or a false statement?
True.
That's a true statement because only one of my statements had to be correct. So what if I say, today is Tuesday or it's raining outside? Well, we're in Florida and it's sunny and blue skies right now. So the raining outside statement is false, but today is Tuesday. And that's a true statement. So therefore, my entire statement is true. Does that make sense?
Yeah.
So here, and Mariam, keep your mic open for a moment so at least one person's constantly can respond. So here, when is, so Mariam, I want you to tell me, thinking about the and, when is the and, when I and two things, P1 and P2 together, when is the and going to be true? When I'm anding P1 and P2, when is the whole thing going to be true? Only when what?
When there are two truths.
Only when they're both true is the quick answer, right?
Yeah.
The whole thing is true only when they're both true. And what about the or? When is P1, so P1 or P2? When is that entire statement true?
Either when it's false or true, true or false, true or and true.
Basically, the quick answer is it's true as long as one of the things is true. They could both be true, but as long as one. Or the easier question I could say, when is this, Mariam, false?
When they're only false.
When they're both false. So the easy way of remembering and versus or, the easy way of remembering is and is going to be true when they're both true. And then P1 or P2 is going to be false when they're both false. That is way overkill of an explanation, but at least we got it done. Let us move on, because we're going to be using that throughout the rest of the semester. So you need to know those truth tables. So here, let me hit stop share for the moment. And I'm going to make a new session and post it into Slack. So hit end, and I'm going to post the new session into Slack.